Hello, and welcome to this detailed exploration of two fundamental concepts in physics, force and torque. These concepts form the backbone of classical mechanics and play a vital role in understanding how objects move, interact, and rotate. In this explanation, we will dive into the definitions, properties, mathematical formulations, and applications of force and torque. We'll also discuss the differences between them, their real-world significance, and how they work together in various systems. Let's begin by understanding force, the foundation of motion, before moving on to torque, which governs rotational motion. Force, the foundation of motion. What is force? Force is defined as any interaction that causes an object to change its state of motion or shape. Simply put, a force can make an object start moving, stop a moving object, change the direction of an object's motion, alter the shape or size of an object deformation. Units and representation. The standard unit of force in the International System of Units is the Newton. 1 Newton is defined as the force required to accelerate a 1 kilogram object by 1 meter per second squared. Mathematically, force is represented as F equals m times a, where F is the force in newtons, m is the mass of the object in kilograms, a is the acceleration in meters per second squared. Types of forces. Forces can be categorized into two main types. Contact forces. These forces occur when two objects are in physical contact. Examples include friction, tension, normal force, and applied force. Non-contact forces. These forces act at a distance, without direct contact between objects. Examples include gravitational force, electrostatic force, and magnetic force. Properties of force vector quantity. Force has both magnitude and direction. Line of action. The straight line along which a force acts. Resultant force. When multiple forces act on an object, their combined effect is called the resultant force. Newton's laws of motion. Force is best understood through Newton's three laws of motion. First law, inertia, an object remains at rest or in uniform motion unless acted upon by an external force. Second law, the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass, F equals m dot operator A. Third law, for every action, there is an equal and opposite reaction. Torque, the rotational force. What is torque? Torque, also known as the moment of force, is a measure of the rotational effect of a force applied to an object. While force causes linear motion, torque causes rotational motion. Units and representation. The standard unit of torque in the International System of Units is the Newton meter. Mathematically, torque is represented as T equals F times R times sin theta, where T is the torque in Newton meters, F is the applied force in newtons, R is the distance from the axis of rotation, lever arm, in meters. Theta is the angle between the force vector and the lever arm. How torque works. Torque depends on three factors. Magnitude of the force. A larger force produces a greater torque. Lever arm distance. The further the force is applied from the axis of rotation, the greater the torque. Angle of application. Torque is maximized when the force is applied perpendicular to the lever arm. Properties of torque vector quantity. Torque has both magnitude and direction. Its direction is determined using the right-hand rule. Axis of rotation. Torque is always associated with an axis around which the object rotates. Equilibrium. An object is in rotational equilibrium when the sum of all torques acting on it is zero. Comparison. Force versus torque nature. Force causes linear motion, while torque causes rotational motion. Direction. Force acts along a straight line, while torque acts around an axis. Formula. Force is calculated using F equals m dot operator A, while torque is calculated using T equals F dot operator R dot operator sin theta. Applications of force and torque. Real world applications of force. Transportation. Forces like thrust, drag, and friction determine the motion of vehicles. Construction. Forces are analyzed to ensure structural stability. In sports, players apply forces to control the motion of balls, equipment, and their own bodies. Real-world applications of torque. Mechanical tools. Torque wrenches measure the rotational force applied to bolts. Vehicles. Torque plays a crucial role in engines, affecting a vehicle's acceleration. Engineering. Torque analysis ensures the safety and efficiency of rotating machinery. In summary, force and torque are two sides of the same coin, governing linear and rotational motion, respectively. While force drives objects to move in straight lines, torque enables them to rotate around an axis. Together, they form the basis of classical mechanics and have applications in virtually every aspect of our lives, from simple machines to advanced engineering systems. Understanding these concepts not only deepens our knowledge of the physical world but also empowers us to create and innovate in countless ways. Thank you for joining this exploration of force and torque.